Welcome everybody. My name is Kevin McDonald. I'm a registered professional engineer here in the state of Alabama. I've been working here at Bentley about 5 years in the certification group. So I do product testing before the products are released out to our customers. Today we're going to be looking at the InRoads 2004 edition, specifically the InRoads Bridge product. We're going to try and look at the tools available to lay out bridge members and report on all the various horizontal and vertical geometries contained in those members, report out clearances and other elevations available from the product. InRoads Bridge has tools that allow you to lay out various members of the bridge. And here's a list of the ones that you can lay out, and we'll go through all these a little bit later during the demo. As you can see, you can lay out the slab fascia, which represents the edges of the bridge deck. There are also tools on reporting the slab fascia as well as edge of pavements. You can also report on layout abutments and pier lines, along with the center line of the bearing lines where the girders bear on the piers and abutments. You lay out the center line and all the vertical and horizontal geometries of the girders, also stiffeners, diaphragms, splice points. All that can be stored in the geometry as well. Also, you will lay out on the substructure the pedestals and girder bearing points, bearing pads. You can also lay out geometries representing the footings and also create geometries representing the slab areas. And again, you can report on all the elevations, screed elevations, clearances, and we'll be doing a little bit of that today. Things you need to model a bridge in InRoads Bridge. Really the first two items that you see there are all that are absolutely necessary. The roadway horizontal centerline alignment that the bridge will be based off of. As you see as we go through the demo, this centerline alignment needs to be active during all of your operations in the bridge commands. Through all the member creation, all the display, all the reporting, this centerline alignment needs to be active. And all the geometry is based off this. Also, you need a DTM representing the bridge deck. This DTM most commonly will come from a roadway modeler run, and it will have the surface of the deck and include any vertical or super elevation that's occurring. And if you're going to use, if you're going to create the footings of the bridge, you're going to want a DTM representing the roadway below the bridge. This will allow you to lay out the footings. It'll allow you to report clearances over in the reporting. So those three things are what you need. So in today's example, we're going to go through just a common workflow using some data we've gotten here from some customers. We're going to first lay out some horizontal geometry representing the bridge members, the abutments and piers, the bearing center lines, the girder center lines, also some substructure locations as far as pedestals, pier caps, and footings. All that is stored in horizontal alignments in the geometry that many of you are already familiar with working with through the InRoads commands. We'll also be creating vertical geometry, slab thicknesses, bearing locations. We'll be creating the girder sections for reporting on clearances. And as we'll see later during the demonstration, you can display all this geometry in 3D to get to be able to view any conflicts or any clearance problems. You can also extrude some shapes, as we'll see later during the demonstration, and we'll provide you with the 3D geometry that'll be a good skeleton to use to start extruding some shapes and doing some rendering in MicroStation. Also, we'll cover a little bit about annotating and reporting on the bridge info. So we'll go ahead and get into the demo now. I'd like to switch on over to InRoads Bridge, and I'll introduce you a little bit here to the data set. I'd like to thank the folks at HDR for sending in a set of plans for us to look at, and they have this very good geometries here on an eastbound and westbound bridge. Has some tricky vertical alignments and some tricky horizontal alignments that we're going to look at and see how InRoads Bridge handles that. As you see here, I have just contours shown of the original ground underneath the bridge. I also have the two bridge decks shown in contours. At the top of the screen, that's the westbound deck, and at the bottom it's an eastbound deck. We're going to treat those as two separate bridges. If I just view the horizontal geometry of this eastbound deck, it shows a little bit of the intricacies that are happening here with this data set. The bridge deck begins in a circular curve, and during the bridge here we have an angle point. It's an actual kink in the alignment where the alignment is not collinear. And then at the end of, so we continue on at a radius here, and again we have another kink in the alignment to where it joins up to the tangent. So the tangent and the end of that curve are also not collinear. So that's kind of a complicated situation. I have a couple of profiles drawn over here to show you some of what's happening vertically. On the westbound bridge, let me zoom in here. You can see that we're in a vertical curve. You can see the roadway below it, and you can see that we're in a horizontal curve as well, and we're in a super elevated section. So for most of the bridge, we're in a full super condition, and near the end of the bridge deck is actually coming out of a full super into a normal crown near the end of the bridge. And the eastbound, which is the one on the bottom on the south side as well, it's in a vertical curve and a horizontal curve. It's in full super for most of the bridge, and then it begins a transition. You can see the center line is drawn there in red. Let me give a chance for the WebEx to catch up. As you can see, the center line of the roadway is drawn there in red, and I have the left and right offsets, 22-foot offset out to the bridge deck drawn in yellow and in purple. So you can see there that it's coming out of a full super condition back down to a normal crown almost by the time the bridge ends. So that shows the complexities there, just of the geometry and the bridge surfaces there that we're going to try and solve. We're going to lay out these members and let InRoads do all the reporting on all the elevations and bearings for us. So what we're going to actually place, let me fit again and zoom back into the bridges. What we're going to actually do is we're going to create two bridges today. Both of them will be two spans, and their piers will be skewed off the center line as well. That's another complexity there that we're going to have to deal with. So let me go ahead and get started walking through the bridge commands. And before I do that, I'm going to clean up my screen a little bit by turning off the contours and just looking at the roadway markings. Alright, the InRoads Bridge commands are all contained in the bridge menu structure here in InRoads. You're very familiar with this InRoads Explorer interface already if you've used InRoads or any of the InRoads products. They are laid out very efficiently. To do an entire workflow, you'll pretty much go from the top of the menu down to the bottom following the command lines. You'll first create slab fascia, then your abutments, then your girders, and then your substructure and your vertical alignments as well. So we'll be walking down through that menu structure today. The first item you're going to create is a slab fascia representing the edge of the bridge decks. And let me get the right geometry project loaded here. We're going to be doing two bridge decks, and one rule of thumb that you have to work with is that each bridge needs to be in a separate geometry project. So I have a westbound and eastbound geometry project here, and I'll be switching between those back and forth as we create these two bridges. So the first bridge we're going to work on is the westbound, the one on top. We're going to create the slab fascia for it. And the slab fascia, again, just represents the edges of the deck. It needs to go from the beginning abutment to the end abutment. It needs to cross those abutment lines when we create them. And it's modeled by, initially by using this command, it's modeled by offsetting the center line alignment that's active. So what I'm going to do is going to come in here and create slab fascia starting at station 12 plus 00 and ending at 16 plus 00, and my left and right offsets are going to be 22 feet. When I hit apply, you can see that the two slab fascia are created. For my eastbound bridge, I'll switch over there. I have some even more added complexity there with my slab fascia. I've already gone and created those by using some of the geometry commands, and I'll go ahead and view those for you. Okay, as you can see, on the left side of the roadway on this eastbound bridge, we have a taper at the end of the bridge that is going into some turn lane or some access lane. So a little bit of added complexity there. We're going to create abutments here in a second. I'm going to switch back to my westbound bridge, and we're going to create the center line of the abutments and piers. The bridge commands here in the create an abutment and piers allow several different methods for creating the abutments. You can just specify a station and a skew angle to the alignment, or you can specify a station and just a bearing direction of the pier. You can also distance from allows you just to offset from some other geometry that you have created, or interactive method just lets you go out there and interactively create key-in northings and eastings, or snap to graphics currently in MicroStation to create the bearing line that you may have gotten from your bridge designers. For this westbound bridge, we have 3 different piers, each at different skew angles. The first one starts at station 1269.22 and is at a 30-degree radial skew. You have 2 options for your skew angle, either radial or tangent to the alignment at the point at the station that you key in. I need my offsets, tell it how far out from the center line to go. I need it to cross my slab fascia, so I'm going to enter in 35 feet here for my offsets. And my girders are going to be bearing 1.5 feet away from the center line of my abutment. So I create that, and you can see it displayed up here at the top. Alright, I'm going to continue to do this for the other 2, for the pier and the ending abutment on this bridge. The next one goes from station 1418.62, and it's at a skew of 25 degrees. Now my bearing line, I'm going to be creating continuous curved girders. So my girders are going to bear directly on the center line of this abutment. So I'm going to create a bearing line directly over the center line of the abutment. When you hit apply, you can see that the graphics created up top here. And the final abutment is 1571.36 at even a different skew angle of 20 degrees. And those bearing points are going to be 1.5 feet back from the center line of the abutment. So I'll hit apply, and it's created that. On my eastbound bridge, I followed the same procedures. I laid everything out using station and skew. So I'll switch to eastbound project, and I'll simply display the bridge. I laid those out earlier. So now that I have the slab fascias, and the bearing lines and abutments and pier lines, I'm going to go ahead and get rid of this last little bit of graphics just to clean things up, and we'll focus in on the bridges. Alright, the next step in modeling my bridge is going to be to lay out the girder center lines. So I'll go to Bridge, Create Girders. It's the next one on the menu structure. And this command provides many different ways to lay out your girder center lines. You can lay them out by just the number of girders, looking at the overhang and maximum and minimum spacing. You can Again, we have an interactive method down there at the bottom. If you are provided coordinates of the endpoints of the girders, or you're provided coordinates and bearings or station and bearings, you can lay that out using interactive, laying out each girder as specified maybe by your bridge designers. We also allow you to lay them out using the maximum spacing. We look at the slab fascia, how much room you have in there, and divide that into what your girder spacing is to place the number of girders. Offsets to exterior girders let you place girders as you go along, offset to girders or any geometry that you've already created. Overhang chord lets you place a chorded girder at a specified overhang from the slab fascia. And you'd use this a lot more if you're not doing a curved section, but if you're just doing a tangent bridge with straight girders, you might use this method. Random longitudinal line, we'll use that in our demo today. That allows you just to place a girder at an offset to a geometry that you've already created. Alright. So I'm going to lay out some girder center lines first. I'm going to switch back to my westbound bridge. And this is a pretty simple bridge. It doesn't have all the geometric complexities that the eastbound bridge does. So I'm going to just do some simple layout on this one. And we're just going to say that we're going to have 8 girders on this bridge, and I've specified some minimum and maximum spacings and some minimum and maximum overhangs. When I hit apply, it's going to prompt me for the first longitudinal alignment there, and that'll be the left side alignment. It'll ask for the second longitudinal alignment there, and then it'll ask for the first abutment or pier line, and then it'll ask for the last abutment or pier line. Alright, let me make sure that I have everything set up here correctly. Again, you need to make sure that your centerline alignment is active throughout the whole, and it is. Alright, and like I said, I see here that I'm going to create not simple straight girders. I'm going to create a continuous span from the beginning abutment to the ending abutment, and I'm going to create curved girders. Let's try that one more time. The left side, right side, the begin abutment, and ending abutment. And you can see there it's given me its first guess at the solution there. I like the solution, so I'm going to accept them, and it's created those girder alignments. So if I look down here in my Windows Explorer, or in my InRoads Explorer, I can see that it's created these girder center lines. Alright, I'm going to switch and do the same for my eastbound bridge. Alright, go to create girders, and for this bridge I'm going to do something a little different. I'm going to create two smaller girders, 2 exterior girders that are going to end up being a smaller section, just to show you a different method of creating both the section later on when we create the verticals, and just the method here of laying out the center line. So the first thing I'm going to do is choose random longitudinal line, and I'm just going to create this girder center line at a 2-foot offset to my slab fascia. So when I hit apply, it's going to prompt me for my longitudinal line and my begin and end. Let's see, my begin and end abutment. And you see there, it's solved that. It's placed. It's paralleled basically the slab fascia. So where I have this taper at the end, the girder is also tapering. So I'm going to accept that solution. And I'm going to create an exterior girder on the other side, a minus 2-foot offset to the other slab fascia. So I'll select this slab fascia and the begin and end abutment. And you can see there that it's drawn that exterior girder. So now I'm going to go back in and fill in the rest of the girders between those 2 exterior girders, just using the number of girder method. Set it to 6. And I'm going to increase my overhang because I've already laid out the 2 exterior girders to 6-foot minimum and 10-foot maximum. When I hit apply, again it prompts me to identify the slab fascia, the begin and end abutment. When I do that, it solves the number of girders, it checks the maximum overhang, the maximum and minimum spacing, and it creates the alignments there. I'm going to accept those. So now I have centerline alignment representing my slab fascia, my abutments and piers, and my centerline of my girders as well. The next step will be to let me maximize this and get rid of it. The next step will be go in and create vertical alignments, so we can start checking elevations and clearances. Before you get into that, you'll see that the next item on the menus is to create additional framing. Well, we're not going to do that in today's classes, but I was going to show you the dialogue anyway. If you wanted to create geometry or points that represent any diaphragms or stiffeners that you might have on the girders, this would be the place to do it. You have many methods here. You can, again, many methods to place those where you need to, number of spaces or maximum spacing. And what this will do is this will just create alignments, again, from the seed name that you specify that represent the locations of each of the stiffeners or diaphragms. But for the next step, we're going to go on and create our vertical information for our girders. And this is a good point here to talk about the type of bridge superstructures and girder structures that you can model in InRoads Bridge. They're all represented right here. We can model standard AASHTO sections, standard steel sections, precast box girder sections. You can also use a constant depth section that is just there for the vertical information only. You can also model built-up plate sections, plate and covered sections. We also will handle U-beams, which some municipalities use. You can also add in correction and camber alignments there if you want that to be reflected in your geometry. Today we're going to be creating steel sections. I think actually the bridge example that we got from HDR had the post-tension box girder sections. Since those are very, very different than the standard sections, InRoads Bridge does not handle the post-tension box girder bridges, but we do handle just the standard section girders that are listed down here. All these sections here in the Create Vertical tabs is stored in the sections.text file. I'm going to switch over there real quick to look at that. You can create any section that you use. We've delivered the standard AASHTO sections here, standard steel sections. This is by no means all the steel sections available, and we have also included in here some standard plate sections. So this can be customized to any section that you're using, and anything that you enter in here in your sections.text file will be available over in your drop-down menu here in the Create Verticals tab. So I'm going to switch back now to my westbound bridge, and we're going to just lay out some standard steel sections for the bridge. You can see that I've got all of my girders listed that exist with that westbound bridge. I'm going to create a slab depth of 11 inches. I'm not going to include any haunch. That's basically any depth above the girder and below the slab. I'm going to use just a standard steel section, a W44 by 290 section, and I'm going to say that it's resting on a 1-inch bearing pad there, and that'll be important later when I create my pedestals and when I report out on the elevation of the bearing points. So I've got all my girders selected, I've got my section selected, and when I hit apply, it creates vertical alignments there under all my girder alignments. We'll go down here in the InRoads Explorer and look at those. You can see created the bottom of slab vertical alignment here and the bottom of the girder vertical alignment, and we'll look at those again a little bit later when we do the eastbound bridge. Switching back now to my eastbound bridge, we're going to do a little bit different. We're going to go to the plate and covered and create some plate girders. And in my example here, I created those two external girders. So I'm gonna go into the geometry filter here and select just those two external girders, and I'm gonna give them a smaller section. So I'm gonna remove those, hit OK. Again, my slab is gonna be 11 inches, so 0.92 feet. I'm not gonna specify a slab to web distance, and my bearing again is gonna be 1 inch bearing pad there. And now I have my girder selected. I'm going to enter in what the plate and cover section is for every length along that girder. When I hit Add After, I get the Add Plate Girder dialog. This shows me the full length of the girder, the distance between bearing points, and I can go along the length of that girder and specify a different steel section as I need to. So for these two external girders, we're just going to say that the entire length is one section. I'm going to enter in 344.66, which is the entire length of the girder. And you can see as I've entered that value in, it gives me where I am along the girder. And by entering in the full length, I'm at the end of the girder, so it says there's 0 distance to the end of the girder. Now for this section, I'm going to say it's just the top and bottom flange are going to be the same, and I'm just going to choose a 10 by 1/2 section for the top flange, and for the web I'm going to say 1/2 by 36 inches. And when I hit apply, it populates the list. This will show you every length along that girder, what the section is. And for these two external, again, I'm just going to enter in this simple section, hit apply, and it has created the vertical alignments for those two girders. So now I'm going to go in and filter and do the rest of the girders. There's the 6 intermediate girders on this eastbound slab. Hit OK, and I'm going to create a new section for these. So when I go to Add After, I'm going to, at the beginning, the first 100 feet, I'm going to specify one section here. And let's see. For the top and bottom flange, it's going to be a 16 by 1/2. These are all the standard sections stored in that section.txt. And the web is going to be a 1 by 54 inches, 1 inch by 54. Alright, and this is just that first 100 feet along the girder. Alright, now for the center section of the girder, 143.47 feet. I'm going to add a bottom cover. I'm going to reinforce, weld an extra bottom plate to the bottom of my flange there. So I'm going to keep the same section. I'm just going to add a bottom cover, another 16 by 1/2 inch plate to the bottom. So what this will do is this will create another vertical alignment for that girder that represents the bottom now of this cover plate. And that'll be important when I go to do clearances off the roadway. I've added another 1/2 inch here, or another inch, based on what I've selected. So when I hit apply, it adds that section in, and then for the last 100 feet of that girder, I'm going to go back. This is going to be the end of the girder. I'm going to go back and say top and bottom are the same, and keep those the same section. Apply. So as you can see, for each of these girder alignments that I've selected, I've built a different section along those girders. So when I hit apply, it creates those vertical alignments. So we can go and look at those now. First, I'm going to show you down in the InRoads Explorer window. I'm going to grab one of those intermediate girders. We'll say girder 5. And as you can see, it's created the vertical alignments representing each of those portions of the girder. It's given me my top flange, my web, my bottom flange, and my bottom cover. So if I review those real quick, this is my bottom cover. Notice I did not have it for the first 100 feet or the last 100 feet, but I did have it for that. I did have the 1/2 inch there at the middle 140 feet. So that's how it's stored there. It's stored as a vertical difference alignment. So reviewing it there in the geometry is one way we can look at it. Another way we can look at it is let me set my bridge center line back active again. We can actually go now that we have all the vertical and section information, we can go to the extrude command and extrude the girders and look at the sections. And that's found under the bridge menu down at the bottom, the extrude bridge. What it does is it places those girders based on the active surface, which is the eastbound deck surface. So I'm just going to look at this real quick in 3D. To show you what it's created. Let me zoom around a little bit so we can get a good look at it. Okay. I want to move it around just a little bit more. Alright. I'll give time for the WebEx to catch up with me. Alright, so here you can see my two external girders are the smaller sections, and then the larger interior girders that I've created. If I zoom in just a little bit more, I'm going to try and find a spot in there. It'll get kind of crowded in there. You can see the bottom flanges here of my girders. I'm going to try and pan a little bit and see if I can find where I added that bottom plate, just to show you that it's drawn it. And you can see it right in here. When we get to that view, you can see the bottom of the smaller exterior girder sections. Then in the interior girders, you can see the bottom of their sections. And you can see right in the middle of the screen there, I have a bottom flange, and it's also drawn my bottom cover there when it's extruded that. So I can see that that station right there on that girder is where the beginning of that bottom plate is. So we can see that it's drawn it correctly there. Alright, we're going to go back to a top view. And I'm going to delete out those graphics. Alright. So now I've created my vertical geometries. The next step would be to create the substructure representing the pier caps, the pedestals, and the footings of the bridge. I'm going to switch back first to the westbound bridge. And like I said, that's the next step there on the bridge menu, create substructures. What this allows you to do is create the top of the substructure. The pedestals and pier caps will be represented by the extension, the lines here that it'll draw. And also the footings can be drawn over there on the third tab. Alright. So for my westbound bridge here, I need to set my bridge surface to the westbound deck. And it's going to build down from there where the girders are and where the pedestal should be. I'm going to, since I'm in a super elevated section there, I'm going to have some elevation drop from my left side to my right side, as I showed in the profile earlier during the session. So I'm going to make my top of my substructure stepped. As you can see, you can have a horizontal substructure and have your pedestals different heights along there, or you can have a sloped pier, or you can do sloped and stepped, or just stepped. And that's what we're gonna create a stepped pier cap. We're going to align these pedestals to the girder, and let's see, the length is measured along the center line of the roadway there. It's going to be 2 feet. The width is perpendicular to the center line. It's going to be 2 feet. And my height is going to be 1 foot there. And these extensions represents how far out from the last pedestal do you want your pier cap to be drawn. So I'm going to say 4 foot out from the center line of that last pedestal. Alright. And when I hit apply, you can see out here that the pedestals were drawn on the center line of the bearing line, on the center line where the girders intersect. And we'll zoom in just a little bit to show that. And here they are. They're aligned with the girder, and they're at the 2 foot by 2 feet that I specified. And if we'll look at a 3D view later, they're at the correct elevation, and you'll see this extension line, which is actually drawn on top of the bearing line right now. You'll see that it is stepped, representing a stepped pier cap. Alright, so we're going to switch over and we're going to do the same thing now with the eastbound bridge. Again, I have to switch geometry projects to work on a different bridge. Alright, I'm going to create the same pedestal configuration there for the eastbound deck. My bridge surface is eastbound deck, and I'm going to use the same settings. Hit apply and create. Now we can also create footings, and when you go to create your footings, we'll start looking at the ground surface. So this is where I said it's not absolutely necessary to have the ground surface below the bridge, but if you want to create geometries that represent your footings there, you're going to want to have that. So I'll switch now to my grading plan there for my topo of the ground underneath the bridge. For my two abutments, I'm going to hit the filter button here again and get rid of my pier in the middle. I'm just going to deal with the two abutments now. They're going to have a combined footing. I'm going to create one footing. It's going to be combined. The total length is going to be 8 feet. Again, that length is measured along the center line. And the width, which is measured perpendicular to the center line, is going to be 60 feet. I'm going to say that's going to be 6 feet below the DTM that I've specified down here. And when I hit apply, you'll see down here that it's created the footing underneath that abutment. And I've created just one one combined footing. For my intermediate pier, there I'm going to hit the filter button. Again, I'm going to swap and select just the center abutment there, just that pier in the middle. Give it a second to catch up. Alright, for this you would have to have information, I guess, from your bridge designers representing, where your column's going to be, and you can enter that here and create the geometry that will give you the coordinates of the footing. Again, my final MG is going to be my ground surface. I'm going to create two footings. My distance left and distance right are going to be 10 feet each, and the length and width of my footing is going to be 10 feet. I'm going to put it at 3 feet below the surface, and those are going to be separate footings. Alright, and when I hit apply, you'll see out in plan view that my two footings were created there. And again, what we've given you here is it's kind of a good skeleton of the horizontal and vertical geometries that you can these are drawn in 3D, so you can go and these are a good skeleton that you can start extruding some shapes in MicroStation and start doing some rendering from what we've given you here. Alright, as we continue down the bridge menus, the next thing we can do is create geometries representing the slab areas. And this will be representing the areas there on the bridge deck. You can create one single slab for a continuous case like I have here. I'm going to create multiple slab areas for each span. Or you can do interactive. Again, interactive allows you to just specify geometry from keying in coordinates and bearings out in MicroStation that you might have. As you go to the Advanced tab, we allow you to specify a back and a head joint width. That'll be on the center line of every abutment. To tell you your slab will go up to a certain distance from the center line of the abutment. And if you have some really skewed angles, you can include breakbacks, which it'll cause your slab area to where you don't have points, that'll crack off there. So we're not going to do that right now. We're just going to say 2 inches there on our joints. When we hit apply, you'll see that it goes out, and then for each span it creates a slab area. And when you accept it, it draws them, and those become horizontal alignments again that you can report on, and they're stored in the geometry project. Alright, and the next command that is available to you in InRoads Bridge is to annotate the screed. And before we get into this, as you see here on the annotate screed, what you're going to be doing is annotating along the girder center lines. You're going to be annotating the bridge surface elevation. And what we allow you to do here is to build in some other vertical alignments to consider, like a camber, your dead loads. We allow you to build in vertical alignments that would represent how the bridge is acting under in those conditions. Those would have been created if we had done that, and I didn't do it for this demonstration. Back here on the Create Verticals tab, let's go back there real quick. Back here on the Create Verticals, the last tab is the Corrections and Camber. And what you would do is select your girder lines there, and you would add any vertical correction alignments or any camber. He allows you the command allows you different methods for calculating the camber, either parabolic or circular, and you specify what the actual depth is going to be at the midspan. Or you can just specify it from a file that basically has a length along the girder or a percentage along the girder. It's going to be deflected a certain amount. So if you wanted to use that, you would create it back here in the verticals, because those would be stored as vertical alignments. And we allow you to include those here on the annotate screed, but we didn't do that for this demonstration, so I'm going to clear that out. And again, you have two methods to annotate your elevations here. You have an interval or events along the girders, or both events and interval. We're just going to do a 10-foot interval there along our girders. And when you hit apply, it goes along and it annotates the bridge surface elevations there. And I'll zoom in. And you can see at every point it gives you an elevation. That's every 10-foot interval along the girders. And again, if we had done those extra vertical alignments, the zeros that you see on the screen are what would show up there from your different vertical difference alignments that you may have created back in the Create Verticals command. But these are your elevations of your surface there, of your deck surface along your girder lines. I'll zoom back out. And the last thing I want to talk about is all the reporting that you can do. Now that we've modeled all of our different bridge members, we can start doing some reporting on elevations, horizontal and vertical coordinates. Again, this makes use of our new XML reports in our XML report browser. The first one I'm going to do is what we just did, screed elevations. I'm going to do some slab elevations. And let me say, the bridge surface you have to set back here on the main tab is the eastbound deck. The ground surface was final MG, and alternate alignment we're not going to be using. Alright, for slab elevations, we can include we're going to get the elevations of the two slab fascia, and we could also, if we wanted to, create elevations along an edge of pavement that would be at some distance inside from the actual slab fascia. We could specify that there, and I'm going to say just include it along the entire limit of my center line. Save as. I'm going to just overwrite my slab XML that I already have there. I'm going to hit apply. The report browser will come up, and I just created a slab elevation, so I'm going to go and select the slab elevation, and I'm going to choose the slab elevations at the piers only. And you can see it's giving me every abutment or pier center line here. So at the slab fascia offset, it gives me the northing, easting, and elevation there. And you see we have different. Again, this makes use of our XML reporting, so you can customize all these bridge reports to report whatever it is that you need. Just some others reports I wanted to show. We'll go over to the vertical clearances tab, and we're going to say yes, include vertical clearances. Again, I'm going to overwrite my report that's already out there. And I'll get to choose an XSL sheet. I'm going to choose, let's see, this clearance report shows me along each girder what the northing, easting, what the bottom of the girder is, and what the ground elevation. is. So you can see as we scroll down here, it shows me that my bottom of girder elevation here at station 1289 is 931.6. My ground elevation is 922, so I have 9 feet of clearance. And what this does is it goes along the center line of that girder, compares it against that the surface representing the bottom of the underneath the bridge, and it compares and gets a clearance along each of those girders. So those 2 exterior girders on my eastbound bridge there are going to be the ones that I'm concerned with. And as you can see, we've created and delivered just a number of clearance reports here. And again, those are customizable for you as you want. The last one I wanted to look at was just going back to the main tab, looking at the eastbound deck again. And I'm going to create just some miscellaneous supports that we're going to look at. We're going to look at the beam seats. For every bearing line, this gives you, for each of those pedestals that we created, it gives the elevation of that pedestal. Girder layout continuous. Like I said, I created continuous girders there. So this, for each girder, gives me the bearing direction and the angle and the girder spacing at the abutment line in this report. And also an overhang report will show you, this would be used more if you created a corded girder, just a straight girder, and you had some curve to the bridge deck. It would show you what your overhang was from that exterior girder to the slab fascia. But since I created mine curved right along the slab fascia, you can see that it's a constant 2 feet along those girders. So that gives you an idea of all the reports that you can create once you've created those bridge members. Alright, and the last thing I want to do is go ahead and I'm going to extrude that bridge again, and we'll look just real quickly in 3D. I know this takes a little bit for WebEx to catch up with, but we'll give it another try here. So again, this shows the 3D representations of my girders, of the top of my pedestals, which would be below the girder and below the bearing pad that I specified. Remember, I specified a 1-inch bearing pad, so if you measure, there'd be 1 inch between my girder and my pedestal there. It shows my stepped pier cap, and it shows my footing at 6 feet below the surface there. So again, all this is a good skeleton there for doing some, maybe extruding some shapes and doing some rendering later on. But all this information is drawn in 3D for you. And again, I have my other pier over here, and you can see my column footings below it. As soon as WebEx catches up, y'all will be able to see that. I had one other slide over here in my PowerPoint. Just some tips and tricks to, as you start playing around with this. Maybe these are maybe some common calls that we've gotten in at the help desk. The first one is you must limit one bridge per geometry project. I covered that during the demonstration there. Your center line must be active during the creation of all bridge members. It has to be active to display the bridge. It has to be active to create any members. Number 3 is that the abutment and pier lines must cross both the slab fascia and the active center line that the bridge is based on. Now today, my center line that I created, and I'll switch back over and show you, the center line top was actually the center line of each deck, but I could have based my bridge off the center line of the roadway, which would be here between the 2 bridges. And if I did that, I could still have used that, but I would have had to extend my abutment and bearing lines out past that center line because they have to cross the center line. It's just to help InRoads Bridge keep track of what all members are related to the center line. And number 4, it's important to maintain the use of the delivered styles for the bridge members. You may have noticed that at every dialog that we went into, create slab fascia, it defaults to a style. It's important to use that style when you create the bridge members, because it creates event points and it creates the geometry, and that's how InRoads Bridge knows that all of these members are associated to the bridge, and that's how it keeps track of it. So I put in my PowerPoint, it's important to use those delivered styles: slab fascia, abutment, bearing, pedestal, footing, and slab. All right, and that concludes my demonstration for today.